Hi again. Welcome to the third segment in this series. Now, let's do a quick recap. What have we done? We learned about a class and an object. An object is created from a class. A class is a template. All right. And we talked about using the new keyword to create an instance of a class. Instance means object. That means to create an object of a class. The process is known as instantiation. Instantiation. You produce an instance from a class. Now, there's one point I forgot to mention. Um, I was saying that you can create an instance of from a class using a new keyword, for example, like that. Now, this statement does many things. All right. First thing it does, it declares a variable called h1 of type human. h1 is an object reference type, as opposed to a primitive or simple type. H1 stores the address of an object. What kind of object? Only human objects. You cannot store the address of a car object. You cannot store the address of a tree object. All right. Java is very strict with variable types. Now, second thing, it creates a new human object. The human object is created somewhere in the computer's memory. All right, that somewhere has an address. Number three, during the creation of that human object from the human class, it calls one of the constructors. All right, in this case, it calls the constructor which takes in nothing. All right, remember, human has got two constructors, this one and this one. The one which got called is this one, the one which takes in nothing. So that is the third thing which has happened. Number four, this expression returns the address of the human object which was newly created. Now this address is then, in step 5, assigned using the assignment operator to H. So H now stores the address of a newly created human object. This human object's name is undefined. This human object's savings is 0. Why? Because when the first constructor ran, it set the name and savings to undefined and 0 respectively. Alright, now the thing which I forgot to mention is that string is very special. Now you can create a new string object like that. This will work, this will compile. Same thing. Declaration of a variable called s of type string. S is the object reference type variable. Second thing which happens, a new string object is created, and the string class has got a constructor which takes in a series of characters, okay, in double quotation marks. Alright, a string object is created, and that constructor runs, and that constructor stores the letter apple in somewhere inside one of the attributes. We do not know how or which attribute. Does not matter. As a user, it does not matter to you. And this expression which I have highlighted will return the address of the newly created string object which is stored in S because of the assignment operator. Alright, the address is then assigned to S. Now I'm saying that string is very special. Why is it special? Because it is so commonly used that there is an exception made for strings. The exception is that when you create a string object, there is no need, okay, to use the new keyword. This is an exception only for strings. In other words, string is the only class from which you can create an instance from without using the new keyword. All other classes, you need to use the new keyword to create an instance. So this is actually valid. Alright? Exception. Remember, this is an exception. In this case, a new string object is created. the address is returned and stored in S2. Alright, so look at these two statements. We have two separate string objects. Okay, one represents APPLE, the second represents ORANGE. The first string object's address is stored in S. The second string object's address is stored in S2. Okay, and S1 and S2, they are referring or pointing to different individual string objects. So string is a special case. Now, follow that what we're going to talk about now. In this session, we are going to talk about how to read the API documentation. Now, API stands for Application Programming Interface. How to read API doc and use classes written by others. Now, most of the time, you will not have access to the source code, okay, of a class. For example, the human class written by me. It is unlikely that I'll give you the source code of the human class, which means that without the source code, you will not know what are the attributes, you will not know what are the available constructors, you will not know what are the other methods available in the human class. Now, how do you use it? You need to know all this information, correct? You need to know how many constructors there are and what do they take in, so that you can use a new keyword to create an instance by indirectly calling one of the constructors. So without the source code, if I give you a human class, I can give you the human.class without giving you human.java. Without giving you the source code, I can just give you the bytecode version, the class file. I need to give you something else. This something else is the documentation, the API documentation. Alright, and this is how it may look like. Okay, index.html. It may look like this. This is the API documentation for the human class I wrote. Now, this documentation is very useful because it tells a user, you, who is using the human class, all you need to know to use it. Alright, you do not need access to the source code. You need access to this documentation. So it tells you this is the human class, a short explanation of what it is used for, and they'll tell you what are the constructors. There are two constructors, one which takes in nothing, the other one which takes in a string. Okay, and the documentation tells you, oh, there are four other methods: get name, get savings, pay, and set name. Now the method signature is provided. If you click on get savings, you want more information on get savings, the method signature is provided, and this will tell you the name of the method, what it takes in, what it returns, and the accessibility. Now, as I was saying, let's hold on to the accessibility, ignore public. And it tells you what it returns. I mean, obviously it returns an int, but what exactly is the number that is returned? It is the savings of the human object. This is how much savings this particular human object has got left. Alright. Now, for example, if I'm interested in pay, this is the signature for pay, the method signature for pay. Sorry. I mean, this is the one. Method name takes in an integer. And what is that? P is actually how much more to pay this human. Alright, and the description of the method, it says it increases the savings of this human object by paying him. So the savings will increase by P. Alright, not replaced by P, but increased by the amount P. And pay returns nothing. So this documentation gives me an idea of what are the methods available and how to call them. That means what to pass in when you call them, and what each method returns, the meaning of the returned value. And this is good enough because using this documentation, I can use a new keyword to create an instance of human by passing in either nothing during the creation or by passing in a string. Alright, and if you're wondering what is the string, what's the meaning of a string that's passed in, okay, the documentation tells you. N is actually the default name of the human object. Okay, I'm going to write some code here, very simple code. I've written a test class with a main method. Now, based on that documentation, I'm able to create a new instance of human by calling one of the constructors. Okay, in this case, let's assume I'm calling the first constructor, the one which takes in nothing. And I'm going to create a second human object which calls a constructor which takes in something. Let's say Mary Jane. So two human objects have been created. For the fun of it, let me create a third one. Okay, H3 equals to new human, and I'm going to pass in Peter Parker. Alright, so three human objects have been created. The first human object, name is undefined, savings 0. Second human object, name is Mary Jane, savings 0. Third human object, name is Peter Parker, savings 0. So let's start manipulating, playing with h1, h2, and h3. Remember how to call the methods. h1 dot pay. Let's pay the undefined human $7. Okay, h2 dot pay Mary Jane maybe $10, and h3 dot pay Peter Parker. Let's pay him a bit lesser. Okay, $4. All right. When I try to retrieve the let's say h3's savings. Okay, I'm actually calling the get savings method of h3. We know that h3 has got a get savings method. Why? Because according to the documentation for the human class, it has a get savings method which returns the savings of the human object. Right? No need access to the source code. Usually you will not have access to the source code of classes written by a third party. Alright, unless your partner wrote it or stuff like that. I'm going to call the pay method of third human again, and I'm going to pay him $5. And then I'm going to call h3's get savings method again. Now let's try and run this and see what happens. Okay, let me compile test.java. Alright, and let me run it. So 4 and 9 will get printed out. Now 4 gets printed out because of this statement. h3.getSavings returns 4. Why? Because h3's pay, h3's savings is 4 at this point in time. I call h3.pay and pass in 5. At this point in time, h3's savings would have increased to 9. And when this statement runs, I'm going to call h3.getSavings again. It's going to return 9, which I print, and that's why the output is 4 and 9. Okay, perfect. Let me just insert another line. Let me try to print out h2's savings. Okay, what will be the output? I'm expecting 10. Okay, because when main started, we have done this. Okay, and h2's savings is 0. Come here, come here, come here, and this will have increased h2's saving to 10. 0 plus 10 is 10. You come here, you come here. Okay, come here, print out this thing. Come to here, and h2.get savings should be 10. What I'm trying to show you is that now these three human objects are distinct, separate, and they have their own savings value, independent of each other, or independent of one another. Save this. Let's try to recompile and run it. And as expected, h2's savings is 10. Okay, so what I've done is I've created three human objects and called their methods. Alright. So what I've done is I've shown an example of an API documentation for a human class, alright, which I have written. Now I'm moving on to taking a look at the API documentation for the Java 7 standard libraries. Now, Java 7 came with a whole suite of classes. We call them the standard libraries. And you can make use of these classes free of charge. Someone wrote them. You don't actually you have access to the source code, but you won't want to read the source code in most circumstances. And all you have to do is to read the API documentation for the classes, and you get an idea of how to use them. All right. Now this is the website which shows you. Now how do you get this? It's not difficult, right? You go to Google and just do a search for Java 7 API doc, and it is here, the first one. Now look at the correct version. If you are using the version 6 of the Java Development Kit, please refer to version 6 of the documentation. Alright, because different versions come with different classes, and use the correct version. I'm trying to say. Alright, so there are three portions, three windows here. The window here on the upper left corner gives you an opportunity to select the packages. Now, what are packages? Packages are basically collections of classes. Classes are placed into packages. So for now, all the classes are shown regardless of their packages. If I want to view only this package java.awt.im, if I click on it, only the classes in this package will appear. Right, for now, let's view all classes in the whole library. Now, in this window on the lower left corner, you see all the classes in the selected package. In this case, all the classes in the library. And there are so many classes. All right, so let's take a look at, I don't know, let's just choose, look for something familiar. I have no idea what is this image icon. Never mind. So if I click on it, it will give me more information about the class. And this panel on the right is quite similar to what I showed you for human. The class name, a brief description here. Okay. Now fields are basically attributes. Then constructors. Wow, this class has got so many different constructors, which means that when I create an instance of image icon, I can do it this way. Image icon I equals to new image icon bracket. Okay, I can also do it this way. Image icon I equals to image icon bracket, and I pass in a string, and this string should be a file name. Okay, so there are different ways to create an instance of image icon because there are so many different constructors. And same thing, these are the methods available in the image icon class. If you create an instance of image icon, you can call these methods. All right. So use this documentation wisely. It'd be nice, it'd be a very good idea to, store this as a bookmark, the URL, because you will always need it. Now, actually, you can download this documentation. Download everything in a zip file. It's a huge zip file. And you may want to unzip it in where you store your JDK so that you do not have to be online in order to access it. Okay, lastly, before I end this session, we are going to look at one example of a library, a class library, a library in the Java 7, a class in the Java 7 library, the point class. Okay, and we are going to use it. So back to my documentation. In this panel, let's search for the point class. This is the one I'm searching for, point. So the point class is found in the package called java.awt. Okay, which means that when I want to use the point class, I'll need an additional statement right at the top. The statement is import java.awt.point. Okay, it's probably not a good time to talk about importing, but I'll show you the statement later. So if you're asking what is all this stuff, what is extends and what is implements, hold on to this. This will be covered in a more advanced topic. You're now at the very beginning of learning Java. Constructor summary. So there are three constructors. You can create a point object by passing in nothing. You can create a point object by passing in two integers, and you can create a point object by passing in a point object. Alright, so we'll focus on the first two. A point class basically is a template which represents a point. That means there's an x and there's a y. So what are the interesting methods available? Get x, get y. Alright, if you remember, these are the getters. The getters for the attribute x and the attribute y. And then we do not have set x and set y. There's no set x and set y, but we do have a set location method. In fact, we have three set location methods. Now this probably is the one which will be useful. Set location takes in two integers and changes the point. That means the x and y represented by the point to the new values of x and y. So set location is a kind of setter. Alright, it's a kind of setter. You have to call it and pass in the new values for x and y. You can't just change x without changing y. I mean there's no set x method and no set y method. Now there's a translate method which is interesting. When you translate a point, you're basically shifting the point. Translates this point at location xy by dx along the x-axis and dy along the y-axis. So that it now represents the point x plus dx and y plus dy. So translate basically shifts the point by these two values. Okay, we'll try to use it. So let's check it out in the test class. Okay, so a main method, like what I've said just now, before we can make use of the point class, we have to add an additional statement. Import java.awt.point. That's the package name right at the top. Java.awt point. So I must have this statement. Point p1 equals to new point. Let's say 5, 5. I'm making use of the second constructor in point, the one which takes in two numbers. Alright, I'll create a second point object and by using the first constructor. It says in the description, it initializes a point in the origin. That means x and y will be 0 and 0. Point p2 equals to new point. Alright, let's create a third point. So the third point represents 0, 0. Same for the second point. The first one represents 5, 5. Now we've got 3 point objects, P1, P2, and P3. Okay, at this point, let's try to draw the memory state diagram. P1 stores the address of a point object. X of point is 5, Y of point is 5. P2 stores the address of a second point object, 0 by 0. And P3, okay, remember these 3 point objects are distinct. This is the memory state diagram. In other words, this is how the memory roughly looks like at this point in time. Now let's do something interesting. Let's call the translate method of P2. P2.translate. 3, 4. Let's review what does translate do. When you call the translate method and you pass in 3, 4, what happens is that the point, which is 0, 0, will shift 3 units to the right and 4 units up. So it will now represent 3, 4. Alright, so P2 should now represent 3, 4 from 0, 0. Let's check it out if that's true. System.out.println P2.get. How do I what's the method name? Check it out again. Can't remember. Oh, so there's no, okay, there's get x and get y. Alright, actually there is a more useful method, toString. Now toString will return a string which represents the point and its location in the xy coordinate space. ToString returns a string. Let's just use it instead. Okay, that's a toString method, and I'm going to call it. I'm saving it, and let's try to run it. Javac test, and let me run it. So this statement is the outcome of line 10. I'm calling the toString method of P2, which basically returns a string. This is the string returned. It shows that the value of x is 3 and the value of y is 4, which is expected. Now I'm going to call the translate method of P2 again, and let's shift it by 20, 1. So P2 should now represent 3 plus 20, 4 plus 1. Alright, if everything goes according to expectation. I'm going to call the P2's toString method and print it out again. Where's my... compile it again because I made changes to test, and run it again. Yep, 23, 5 expected. Let's experiment a bit more. Now I'm going to do something like this. P3 equals to P2. And then I'll try to print out the value of the I'm going to call toString of P3 instead of P2. What do you think will be printed out? Is it 0, 0? Or is it 23, 5? So the question is basically, when the program runs line 14, what happens? P3 equals to P2. What does that mean? Now, this assignment operator, it means the value stored in P2, save it in P3. Now, what is the value stored in P2? It's the address of the second point object. Now, at this point in time, okay, when I'm at line 13, P2 should represent 23, 5. Okay, let's update my diagram here. This should be 23 and 5 at this point in time. Okay. Now I go to line 14. P3 equals to P2. P3 equals to P2, which means the value in P2, store it in P3. So what is the value in P2? This is the value in P2, the address of the second point object. So the address, which is the value in P2, is copied over to P3. Now, which means that P3 now refers to the second object as well, second point object as well. This is how it will look like visually after this statement. Both P3 and P2 will be referring to the same point object, the second one. Now, you'll be asking what is going to happen to our dear third point object. Now, point objects, or any object with no variable referring to it, will never be usable anymore, because if you do not have its address, you can't use an object. So eventually, the third point object will be what we call garbage collected. It is garbage. Okay, I'm not going to talk about when garbage collection occurs and stuff like that. Just know that um, occasionally the Java virtual machine will do some processing to search for all these objects which are not stored. I mean the objects which are not referred to by any variable and garbage collect them. So you can never make use of the third point object once you lose its address. Alright? So at this point in time, I move on to line 15, and line 15 calls p3.toString. p3.toString, alright, you are trying to call the toString method of the second point object, which returns you a string showing 23, 5, alright, and is going to print out 23, 5. Now let's try save. Let's see if I'm correct. Okay, compile, run. See? The third output here corresponds to line 15. Now, when I do p2.toString, it's the same as, put it away. When I call p3's toString method, I'm actually calling p2's toString method. They are both referring to the same point object. So be very careful of this. Alright, you can do this with object reference variables p1, p2, and p3. You can't do this with primitive type variables, because primitive type variables, you can't have two different variables referring. They don't refer to anything. They store a value. Okay, and the value is the integer or the float or the boolean. Now for object reference types, you can actually have two variables referring to the same object in memory. Okay, so I've shown you an example of how to read the API documentation, okay, of a class in the standard library, in the Java 7 standard library. In this case, I use the point class. You should be able to make use of any of these classes, okay, in the library. There's so many classes, as long as you have access to the API documentation. I do agree that some parts of the documentation are not well written, and you have to experiment a bit. Okay, that's all I have for you.